Hi, my name's Frank Thomas. I'm with Adaptive Corporation's Metrology Solutions Group. Today's demonstration is going to be on VXElement software and VXModel software. VXElement is a piece of software that comes bundled with Creaform 3D scanners. All of their 3D scanners. It's no-charge software. VXElement is used for capturing the 3D scan and editing the 3D scan to do some basic cleanup. You can also do things like merges and some other cleanup utilities. So we're going to be showing you some of that today. Specifically, we're going to be doing a merge today. And then we're going to get into VXModel, give you just kind of a quick overview of VXModel. VXModel is used to do some additional advanced cleanup on the mesh itself before you output to downstream applications to do some further reverse engineering. So VXModel is a great kind of a pre-processing tool for reverse engineering. A lot of capability with it, and allows you to create some CAD elements as well, or CAD entities that can be output to downstream applications. We'll illustrate that here for you shortly. In today's example, I've got a motorcycle seat that we basically scanned. And what you'll notice about this motorcycle seat is that I scanned the top of the seat, and then I hit File, Save As, and I called it Seat Top. And then we started a new session in VXElement. We flipped over the seat, and we scanned the bottom of the seat, and we said File, Save as Bottom. So what I want to do is I want to run through the workflow here today to do a simple merge. This is something that people do a fair amount of, and VXElement is built to accommodate this very quickly. I think it's very intuitive. So to start, we're going to, we've got the seat top open. We're going to say Merge Scans, and we're going to say I want to add a scan, and we're going to merge to or select long seat bottom here, and we're going to say open on that. So what we're doing now is we're opening up two scans into one session, and there are a couple of different alignments that we can do. We can do a best fit alignment, or we can do a target alignment. I use targets on these parts, and target alignments always are going to be the most accurate. So anytime you have an option to use targets, we would prefer doing target alignments. It's kind of like a datum alignment. So we're going to say go ahead and activate the targets. And a target alignment, I need minimum of 4 targets in common between the top of the part and the bottom of the part. It defaults to 4. We're going to say go ahead and align the part, so you can see that quickly it aligned top and bottom. That looks good, so we're going to say accept that, and we're going to go ahead and merge those two scans together. So by merging, what we're doing now is we're opening up a brand new VXElement session. We're taking the top and the bottom in the proper alignment that we just created, and we're merging that into a brand new session. Once we got it into the brand new session, we can do some other downstream kinds of things with it, and that's what we're going to cover with you here shortly. Okay, now that we've merged the top and the bottom of the part, you can see that we've got the bottom, and it's connected to the top of the part. Looks good so far. So at this point, we're going to do some downstream kinds of things to it. We're going to use VXModel to do that. So VXModel runs inside of VXElements. Basically, it's just a module, an add-on module for VXElement. When I hit VXModel, it gives me some other menu options. Run through some of the utilities in here. One of the first utilities that I like to show people is the Clean Mesh utility. So what the Clean Mesh utility does is it goes through my part, it evaluates my scan, and it finds any nonconformities in the scan that can quickly and automatically clean up without any user interaction. So I'm going to say go ahead and complete those. This takes a few seconds to do that. Then after we get done with this, we're going to take a look at the second utility that I like to highlight for people, and that's the hole fill utility. So if I hit fill holes and then rotate the part, you can see that it's highlighted some areas that the Clean Mesh utility did not take care of. So any of these highlighted areas that have the pink boundaries on it, those are gaps in the mesh. So to clean that up with the fill hole utility, there's a couple ways to do it. One is automated, the other one is manual. To show you the manual first, I just click on the boundary once and it cleans that up for me. I click on the boundary here, it cleans that up for me, and so on. So I can kind of work around the part here quickly and fill holes and gaps as I go. right? Or to do it automatically, I just take the slider here on the left and I say, well, there's 15 other gaps in the part. Let's go ahead and apply those and go ahead and automatically clean those up. And it's completed that and I'm done. Okay, so now I've got a part that should be watertight, and I can tell you whether or not that's watertight. We have one button here that says watertight remesh. If I hit that, it says that the mesh is already watertight. So basically what watertight means is that now the part, if I wanted to 3D print this on virtually any 3D printer, it's a watertight STL file that if I hit File, Export Mesh, you'll see that now I can output a STL file, and STL is a native format for 3D printers, as you may know. Let's show you one other capability that I think has some appeal to some people for downstream applications, and that's the auto surface capability. So we're going to say go ahead and automatically surface this part, and if I hit the preview button, this process takes about a minute or two. It kind of depends on the size of the part, but basically what we're going to do is we're going to put a NURB surface across the top of my part on both sides, and that NURB surface then can be output as a IGES or step surface to, again, downstream CAD applications. Okay, so now we've completed the auto surface, and you can see that that worked out pretty well. And we can go and highlight that now to show you better what we've got. I'm going to turn off the scan, and I'm going to turn off the mesh itself, and we're going to keep just the surface turned on. So at this point, if I say File, and if I say Export the surface, all entities, I can export that surface as an IGES or a step file. I can also save it into SolidWorks directly or a variety of CAD systems. So we support a direct link from VXModel to SolidWorks, Inventor, or Solid Edge as well. So that concludes our presentation for today. Please keep Adaptive Corporation in mind if we can be of any help for you. And our email is here on the closing. Thank you for joining us today.